In this lesson, we'll show you how to run the Clash. Now before you can actually run the Clash, you have to set first the type of Clash that you want to run. Navisworks provides 4 different types. Before we choose a type, or get started on the Clash test itself, first I want to describe to you what the different types are, so that you can understand when it comes time for you to run your own Clash test. The first type is hard. What this does is it runs the Clash test on all the points of intersection between the different geometries. Now, when we say geometries in Navisworks, what that means is that all the different components are made up of triangles that are then combined to form the overall geometry. Hard conservative uses a very similar process to the regular hard, where it checks to see if any of the triangles that form the geometry intersect. The difference between normal hard and conservative hard is that conservative will go a little bit further to test for situations where the triangles may not intersect, but a clash could still take place. For instance, if you have 2 pipes that are running exactly parallel, but they overlap each other a little bit at the end, technically none of the triangles that form their geometry are intersecting, but it still would cause a clash. The hard conservative method will identify this, and it will notify you of the potential problem when you run the clash test. So in essence, hard and hard conservative perform the same basic check, but hard conservative will be a little bit more rigorous, and it will give you any situations where there might be a clash. Now, one thing to be aware of is that this may produce false positives, that is, situations where there won't be a clash, but based on the algorithm, it says that there may be. This is something you need to take into consideration when you're running a clash test, but it's often better to be overcautious rather than encounter a problem further down the line. The next clash test type is clearance. Clearance tests will check not to see if any pieces of geometry intersect, but only if they come within a certain range of each other that you can set. This way, you can see if any pieces of geometry are too close to each other, based on what parameters you set. The last type is duplicates. This checks your model for any duplicate geometry to make sure that you haven't accidentally included the same part twice. For this example, we'll run hard conservative, since that has the greatest chance of showing any discrepancies. Also note that you can always link a timeliner, although we're not going to for this example. The last thing we want to make sure we do is click the checkbox that says Composite Object Clashing. This is a relatively new feature, first introduced in Navisworks 2014. It ensures that if there are duplicate clashes within the same composite object, that you won't receive multiple notifications. Functionally, it actually replaces 2 separate commands from previous versions of Navisworks: items in same composite object, and items in previously found pair of composite objects. It just tries to simplify and streamline the process of clash detection, so it can keep you from going over the same thing repeatedly. So make sure the checkbox is pressed, and then click the Run Test button. The window will change to show you all the clashes that it detects. Right now it only finds 2. So I'm going to go ahead and reduce the size of this window, so we can actually see the model while we explore the clashes. So as you can see, one of our clashes is already displayed. It's the bright orangey red beam. Give me just a few seconds to get this oriented right. Okay. One thing I want you to notice is that you have display settings options on the right-hand side of the panel. You can either dim the non-clashing components or hide them altogether so that you can only see the parts that are clashing. So when you activate that, all you will see are the selected clashing components. Now if we go ahead and click on Clash 2, that will change our view so that it hides the first clash and only presents the second. So let's try another clash test. You can always press Reset All, which will reset the clash and let you start fresh, or you can add a test, which won't undo the first one that you ran. So we'll do that. So right now we have Test 2 selected, and because we haven't actually set any parameters or run it yet, you'll see that our view window is just our normal model. So we're going to change the name of this test to Clash Structural Only. So that means this time we won't be comparing it with the MEP models. So we're only going to select the NWD file. We're going to make sure we click the self-intersect option, and then we will run test. This time it brought up 194 clashes on the hard conservative setting. So right now, with the rest of the model hidden, it's not very useful for determining where the mistake might be. All you can see is the isolated staircase. So if we go ahead and select Dim Other, that will present a dimmed version of the model, which lets us put in context where the clash is. So as we start clicking through the different clashes, you'll start to notice that a lot of them seem to be staircases. As we get further on, you'll notice that there are beams that start to become problematic, but they all appear individually as you click on each clash. So also remember that we have both of our clash tests available at the same time. So we can go ahead and click on the first one that we ran, Structural versus MEP. And now we'll right-click on it to reset the clash test. Okay, now we will go to the Select tab, scroll up to the top, and under Selection A, we'll select project1.nwd, and under Selection B, we'll additionally select project1mep.nwc, while then deselecting the NWD file. Now when we run the test, we find 22 clashes, and most of them appear to be beams that intersect each other where they shouldn't. So you can continue clicking on through them and get a feel for where all the different clashes are. Another option to be aware of is the transparent dimming checkbox under isolation. This turns the rest of your model a dull matte gray while highlighting the clashes, so you can see how they actually fit in 3D space a little more easily. So as you're doing clash tests, remember to check those options to give yourself the full availability that Navisworks provides to explore the problems.